In Math 3-1, today we are going to use and talk about different types of identities here. Not the Pythagorean ones or the reciprocal identities that we talked about in the previous class or lessons. Now we're going to talk about what we call sum and difference identities. Now, sum and difference identities are useful because they allow us to find exact values for angles that are not on the unit circle, like 30, 45, 60, 90, 180, et cetera, those kind of angles. Now, as long as we can make an angle up using those pieces, maybe I can use 15 degrees. 15 degrees would be 60 minus 45, right? So I can get 15 degrees, 60 minus 45, yeah, 15 degrees. Or I go the other way, 45 minus 30, doesn't really matter. But if I could create those angles using those unit circle numbers, I can determine what those values are. Or I can use these identities to help us prove other identities as well, right? So if you haven't already if you want to, you can watch the optional video that proves at least the sum identities here, the sine alpha plus beta and the cos alpha plus beta. And it gives you a little hint of how you can solve the negative ones and the tan as well. Otherwise, just whatever's inside this box just holds true. Just take for granted that it works. If you don't want to watch those videos, you don't have to. But it'd be nice if you look at those, look at what's in this box, try to recognize parts of it. Like if I ever see a sine, cosine with a sign in or a plus sign in it, then I know that's that identity. Or if I see cos minus sine, then I know it's the sine or the cosine sum identity. Or if I see cos plus sine, then I know it's the cosine minus identity, et cetera, et cetera. Or if I see this kind of really messed up thing of all these tans in there, then I can simplify it down to this as well. Okay, so say you have these here. So cos 180, cos 80, sine 80, sine 100, sorry, cos 100. So I'm looking at that. I'm going to ignore this one at the top here. See, all this shows that this doesn't work if you try to do this one. It doesn't work out for us. Does it actually hold true? Let's just do that one quickly. So I'm going to try to verify this. So I'm going to go sine alpha plus beta. So that means I'm just going to add those two angles together. So that's going to be 90. Does sine 90 equal sine 30 plus sine 60? Well, sine 90 straight up, that's going to be my y value, so that's going to be equal to 1. Sine 30 is a half, that's why I wrote a third, and sine 60 is 3 over 2. 1 plus 2 over 2. No. So this is what we call a counter proof. If someone said, is this identity true? You'd be like, rather than trying to prove it or disprove it generically, I'm just going to give you a counter example. Here, what if 30 and 60, if it's identity, it should have worked for 30 and 60, unless it was one of the restrictions. So let's use the known identities here to try to simplify some of these things down. So if I ever see like cos 100, cos 80 and sine like that, I'm going to go up here. I'm going to try to match it to one of these. So it's cos plus sine, cos plus sine. It's this bottom one, cos plus sine. So this will simplify down to cos alpha minus beta, which will simplify down to cos 20 degrees. Okay. Now I'm going to look again. We're going to look at this one here. This is going to be sine cos minus cosine. So it's a minus 1 with a sine cosine. So it's not going to be the cos ones. Sine cos minus cosine. Okay, so this is good. So that's going to be sine pi over 3 minus pi over 6. Okay, so you notice that this is going to be the alpha. This is the alpha. Yeah, it has to be it's very specific about this one. It's got to be in that kind of order where alpha is on the sine and the alpha is on the cos here, because it's alpha is on the sine and the alpha is on the cos here. Okay, So order is very important there. Then you're going to pull out your calculator, simplify down, which is going to be 1 over, what am I talking about? It's going to be sine pi over 6. Right? If else fails, just go 1/3 minus 1/6. Math, enter, enter. 1/6 again. Cool. Now you can always reverse it. Like here, I have sine or cos 20. Cos 20 can be made up of 2 angles, or sine pi over 6 can be made up of 2 angles. Right? So same thing with this. Sine 75. Sine 75 can be made up of 2 angles. I can subtract 2 angles. I can add 2 angles. Later on, you can double an angle and say, okay, I have, well, it doesn't really work too well for us for the double angle one, but for the sum one, we can. What 2 angles would I add together or subtract to get 75? Well, 30 and 45 work. Well, you could pick any, you could pick, if you wanted to, you can go, I don't know, what would you do here? Yeah, that probably wouldn't be a very good one for us. No, that wouldn't work for us. What if I said 120 minus 45? Yeah, so I can go 120 minus 45. I could do that. I can pick all, as long as the angles off our unit circle, I can pick them. Okay. I'm going to do the top one because everything lands in the first quadrant here. So you go to your sine plus identity. If you want to do this bottom one here, you can do the sine minus identity. But the plus identity is going to go sine cos, cosine. So sine alpha, I decided 30 was the alpha here, cos beta plus cos alpha sine beta. Okay, then using our unit circle knowledge, which I'm just going to draw them over here. 30 degrees right here. 30 degrees is root 3 over 2 and a half. I knew that one because we did that one before. And then 45 degrees is root 2 over 2, root 2 over 2. So that's 30 degrees, 45 degrees. That's just a side note on the side there. So sine 30 degrees is going to be a half. That's the y value. Cos 45 is going to be root 2 over 2. Cos 30 is going to be root 3 over 2, and cos 45 is going to be root 2 over 2. Okay, we're going to simplify this down. So it's going to be root 2 over 4 plus root 6 over 4, which is going to be root 2 plus root 6 all over 4. Looking pretty good. That's a nice little exact value of that one. It's a little bit trickier when you're talking about radians. How do you figure that one out? Over 12 is not one of our unit circles, but it is a nice number if I punch in my calculator. Is it a nice number? 5 pi over, yeah, so I put over 120. 75 degrees again. So all of this ends up being the same as saying cos 75. Okay, so if you need to, just change it into degrees because it's a little bit easier. And I want to pick 2 angles. I could do the same thing, but this time I'm going to mix it up a bit. I'm going to do the 120 minus the 45 this time. Okay? I'm just going to mix it up. You could use 30 and 45 again and do the same thing. But why do that? Why be the same all the time? Okay, so the cos difference one says cos cos plus sine sine. Okay, cos cos. You notice that this 45 doesn't have a minus sign in it because the difference one has alpha minus beta, but all the betas are positive on the other side. Technically, you could make this a sum identity for saying 120 plus a negative 45 and then use the sum one. don't know why you do that either. Okay. So 120 lands in this quadrant here. It's 120 degrees. Its point is 60 degrees there. Its x value is -0.5. It's in the negative quadrant for the x values. But it's going upward, so it's positive √3/2, 60-degree reference angle. And 45, which we already know is in this quadrant, √2/2, or 2/2, or 1/√2 if we want to. It's up to you. Okay, cos is my x value, so it's going to be -1/2, 2/2. Sine is my y value, √3/2, √2/2. Okay, simplifying this down, so I got -√2/4 plus √6/4. So this ends up being √6 minus √2/4. I just switched the order so we had the positive first. You could have left it -√2 plus √6. Cool. Where are we on this video here? 11. Okay, so we can do one more here, and then we'll come back in the next video to talk about these other ones here. Cool. Yeah, I like these. That last example here. It's a fun one. Okay, so tan 105. What two angles would make 105? You think about that. So one way to do this is just pull out your calculator, go 105 minus one of the angles that we know, like 60. Oh, okay, so 60 and 45 would make that. 60 plus 45. Okay. Then you're going to pull out your identity sheet. Find your tan sum identity. This is the really complex one here. You're going to go tan 60 degrees plus tan 45 degrees. That's on the top there. Yep, that's the plus one. Okay, and then 1 minus tan 60 degrees, tan 45 degrees. I like putting parentheses around things. I'm just going to do that. Okay, so I got to find out what tan 60 and tan 45 is. So 45, again, remember, is √2/2. √2/2. But tan is y/x. So tan 45 is equal to 1. Positive 1 because it's in the first quadrant. Well, the other one's going to be positive 2 because it's also in the first quadrant. But it's not going to be 1. At 60 degrees, my x value is 1/2. My y value is √3/2. Okay, you notice that that's opposite the one up there. Tan is going to be, remember, tan 60 is going to be the y value over the x value, the opposite over the adjacent. 2's reduce out. This ends up being √3. Okay, so now what I know, I'm going to just replace those in here, is that tan 60 is √3 plus 1 on the top, 1 minus √3 times 1. Times 1 doesn't do too much. Okay, so that's what we have here. This looks pretty good. So you can leave it that way if you wanted to. If we're trying to simplify this down a little bit, make it look a bit nicer, we're going to rationalize this. I don't know if they're going to make it look nicer or not. Actually, this might look a little bit more ugly. So 1 times 1 is 1 minus, because negative positive turns into negative there, √3 times √3 is going to be 3. So I have a -2 on the bottom. I'll deal with that in a bit. √3, 1, so I'm going to do a whole distributive property here. Okay, so √3 plus √3 times √3 is 3 plus 1 plus √3. So I'm going to have 4, 3 plus 1, plus 2 √3s We're going to reduce this down. Everything can be divided by 2. All the coefficients can be divided by 2. So let's divide them all by 2. So 4 divided by 2 is 2. I'm going to do with the negative as well. I'll just do with the numbers first. We're negative 1. And then I'm just going to move the negative to the top here. So negative 2 minus root 3. That's my final answer there. And you can double check that. You got a calculator. You want to see if you did it correctly. You go tan 105, making sure you're moding your calculator using degrees. Okay, tan 105. I get this negative 0.3 or negative 3.732. Then you go negative 2 minus root 3. I don't know if you can see it. They are the same number when you do that. So it worked out. Cool. There's the exact value. That's the exact value, right? So what's in your calculator is not an exact value, right? So that number is an approximate number. I can write like 9 decimal places, but once I stop, it's no longer exact. Okay, so our next video here, we're just going to do 2 quick little examples. I want you to try this out as well. Can you determine what cos 15 is? 15 degrees. This bottom one's a little bit trickier. Well, I may go over that one. Let me get back. I'll see you in the next video. Bye.